Hello and welcome back to the Slackware ARM vlog. If you're new to the vlog, Slackware Linux is the oldest actively maintained Linux distribution in the world. It's run by Patrick Volkerding with a small group of international volunteers, most of whom have been in the team for, I don't know, well over a decade for the most part. Usually probably more than that actually, probably 15 years or so at least. And this vlog is really about covering the ARM port of Slackware. So that's about running Slackware on things like the Raspberry Pi, Rock Pro 64, Honeycomb LX2, and various other things. The ARM port's been around for about 22 years at this point. I started building the ARM port in January 2002, so it's been going for over 22 years at this point. And during the first COVID lockdown, I started porting it to ARM64 or AArch64 as it's called. So that's the 64-bit version of ARM because I had nothing else to do. So, well, he's locked at home. Why not upgrade it to 64-bit? It took a lot more work than I was expecting to do. But fortunately, one of the Slackware team, Brent Earl, joined me to help with the porting efforts, which is a really big deal because it'd pretty much just been me on my own with some help from various friends to do certain parts of the stack. And since then, Brent's been a co-developer of Slackware AArch64. Now, before we get going, I just want to say thanks a lot to those of you who support the project by donating. I'm probably one of the only people on YouTube who will ever tell you that I don't really mind whether you subscribe or like the videos at all. I genuinely don't. That's because I don't make any money off of YouTube. You have to upload certain numbers of videos per week and stuff like that, and I'm just not interested in that. That's not the purpose of this project. The project is about building Slackware on the AArch64 platform. So if you actually do like the project and you use it, please feel free to donate what you can because it really is appreciated. All of the machines that build the Slackware ARM project or involved in it are actually at my house. So they consume my electricity. We don't have any backing. Slackware has no corporate backing or anything like that. It's purely down to the users that help keep the project alive. So if you want to help with the project, please feel free. I'll just show you how to do that now. Go to arm.slackware.com in your browser. Okay, and then on the left-hand side, you will see funding and donations. So click on that and it will tell you how you can help support the project. One of the other things I'll draw your attention to here is supporting upstream Slackware x86 or x86-64. There's never really much noise made about supporting Slackware financially like this, but without it, the ARM port won't exist. You can help support Slackware x86 by picking these two, and those will take you to Patrick's donation pages. In this episode, I'm going to show you what I've been working on recently. If you've seen some of the previous episodes, I've been creating a tool called SAIR, S-A-I-R, which stands for Slackware AArch64 Installer Respin. Essentially, it's a tool that allows you to take an existing Slackware installer image and make some modifications to it and provide you a new version of the image. The reason I've built this tool is because if you can see actually just over there, there's a building, and in that building is a TV that has nothing connected to it. It's a really old smart TV that is so old, like over 12 years old I think, and the smart stuff just doesn't work anymore at all. Like it doesn't have, like the Netflix client on it doesn't work because Netflix doesn't support this old Samsung TV. Basically nothing works on it at all. What I normally do is just put a little small media machine, like in fact, well, you can't see it, I'll show you later, but there's one over there. It's a really small, I think that's an AMD Ryzen machine, like a super small x86 machine. And normally I'd use that as a media machine, but I thought instead of doing that, I'm going to use an ARM machine instead. And what better machine to pick than a Raspberry Pi 5, because they're pretty powerful for what they are. We can get a 16 gig RAM version, which is important for future proofing, because I don't want to buy something with like only 8 gigs of RAM, because I know it may sound like a lot, but actually things like browsers eventually just use more and more RAM. So to me, I'd rather have something that has a lot of RAM up front, so that's good. And it allows us to be able to support the Raspberry Pi 5 officially in Slackware, because it's myself and Brent that does it. So for me, that means I need to have a machine so I can test it and do some of the development. Now, the problem is that the developers have their own fork, their own copy of the Linux kernel, which is normal, right? That's how development is done. But the challenge comes when it takes them quite some time to get their changes into the upstream Linus Torvalds kernel, the official Linux kernel, which is what we use in Slackware. Slackware is a purist distribution, which means that we try to not patch any of the software as much as we can. And certainly, I don't mind applying a few kernel patches every now and then, or rather not. But currently, Slackware AArch64 has 0 kernel patches in it. It's a pure virgin kernel from kernel.org. And I'd like to keep it that way. But I don't mind applying a few patches, but I'm certainly not going to take an entire separate software repository and ship that as a kernel as part of the official release. So what that means is that we'd need to wait until there's adequate and stable support in the Linus Torvalds kernel. And the thing is, it could take absolutely ages. I mean, when we first released the Raspberry Pi 4 support into Slackware AArch64, it did work, but it was a bit unstable. I mean, it's okay now, but it has been like 5 years. So for me personally though, I don't mind using the Raspberry Pi kernel fork at home. I'm just not going to ship it as part of Slackware as the official release. So I built this tool called SAIR, which allows me to deconstruct the official Slackware Raspberry Pi installer image, which currently is for the Raspberry Pi 3 and 4, and it allows me to modify it as much as I need to so that I can replace core components of it in core configurations. For example, I'll replace the kernel with the Raspberry Pi kernel fork. I'll change some configurations to make it work properly with the Raspberry Pi kernel fork, and then I'll just rebuild that image so that I can then install it from an SD card as I normally would. Now, we already support Slackware on the Raspberry Pi 4, so if you want to do that, I'll just quickly show you how to do that. It's really easy. So the way to install Slackware on the Raspberry Pi 4 is go to arm.slackware.com. Then click on the installation guides on the left-hand side. Currently, we don't have a stable release as of October 2025, so at the moment we'll use the development branch. So we click on, go to development branch, and you want the 64-bit architecture. So the development branch is called current, click on that. Then find the Raspberry Pi 4 and click on instructions. Now, this used to work on the Raspberry Pi 3. I don't know if Slackware still does work on the Raspberry Pi 3. It may do. We don't have a Raspberry Pi 3. Brent had one, but it broke. So I don't know whether it still works. Raspberry Pi 4, it definitely does because I've got one. And so here's the installation instructions. So you can follow these. They may look quite long, but actually it's just really well documented. So it's pretty easy to do. Okay, so that's how you install Slackware on a Raspberry Pi 4. Okay, so let's now use SAIR to build ourselves a new version of the Slackware AArch64 installer for the Raspberry Pi 4. Note I said 4, not 5. That's because I'm building it for the Raspberry Pi 4 because I have a Raspberry Pi 4 already, and that's going to take me quite some way towards making it work on the Raspberry Pi 5. So just testing it on the Raspberry Pi 4 allows me to get all the core components in place before I purchase the Raspberry Pi 5, and at that point I can make some future progress. Or Brent already has a Raspberry Pi 5, and he's told me he's already started working on the Raspberry Pi 5 plugin for SAIR. So maybe he'll do it for us and I won't have to do it, which would be great. But for the time being, I'll just show you what I've done for the Raspberry Pi 4. So we're going to run the SAIR tool now. If you guys want to play around with SAIR, if you want to produce your own spins of the Slackware installer, if you want to try and get Slackware running on other hardware models and you know how to build kernels and stuff like that, you might want to have a play around with it. If you go to the Slackware ARM FTP site, which is ftp.arm.slackware.com, and then click on the Slackware ARM repository name here, click on that, and then go to Platform, AArch64, Bootware, SRC, SAIR. That's where it lives, in here. Right, now I've opened up my VM, and we're going to run SAIR here. So
if we do SAIR, actually, what are the options? Oh yeah, right. So -s/devel arm slack. Oops, distribute BCM. BCM. Okay. -d RPI4.image SAIR, and then -m RPI4. So what this is going to do, this will take the official Slackware installer image, which is this one here. So this is the Slackware installer packaged for the Raspberry Pi. So this is the installer image you download if you follow the instructions that I showed you earlier. So it'll run its modification functions, and then it will output a new version of the installer image into /tmp. And this -m here, this means run the Raspberry Pi 4 installer modification script. So it's currently going to decompress the image because we ship them as LZMA compressed. At the moment, SAIR only supports the SD card images. It doesn't support ISOs. I may add support for ISOs in the future, but at the moment I don't personally need it, so it doesn't support it. Okay, so it's running now, and it's made a few changes. It's repacking the installer. You can see here that we've just replaced the official Slackware kernel with the Raspberry Pi kernel fork version. Okay, done. So unfortunately, within UTM, we can't address a external USB SD card reader, for example. I have tried. Apparently you can do it with the QEMU emulation, but not with direct virtualization. So I'll just copy it to my x86-64 box and dump the image onto the SD card from there instead. So PAV dump / what did I call it? So yeah, so kit :/tump. Okay. Okay, so the new installer image has been copied to my x86-64 machine. So let's now move over to that machine, dump the image to the SD card.
Okay, so this is the little machine I was telling you about earlier. It's just an x86 that I use for my desktop. So I've got my micro SD card here for the Raspberry Pi 4. Put that in there. You can see here that the SD card can be addressed on /dev/sdb. So we just need to dd the image. So you can see I've done this before, but it is not called, we have a different name this time. So there we go. Okay, so let's leave that to dump the Slackware installer image onto the SD card, and we'll return when it's done. Okay, so it's finished dumping the installer image to the SD card. So we've run sync already, so all the data is written to the SD card. So I just need to unplug it and remove the SD card. Okay, so now I just need to insert it, the SD card, into the Raspberry Pi 4 and then turn it on. So if I remember rightly, yeah, there we go, it goes that way around. So let's pop that in like that, and then we just need to turn it on. Okay. Right, so we should see the, oh, there we go, yeah. Hopefully that's, okay, that's cool. Right, so we'll see the installer booting. You can see we've also got we've got serial access as well here. And you can see here, so what we're going to be using though is the HDMI monitor and keyboard, because that's what's documented for Slackware AArch64. You can also SSH into it though, into the installer if you want to. You could also conduct the installation over the serial console as well. So this here, this is the output from the serial console. So that x86-64 machine you saw me plug the SD card into, that is connected over the serial port using a USB to serial converter to the Raspberry Pi 4. So that's why we've got access here as well. But again, we'll be using the monitor and keyboard. So I'm just going to press enter here. So I'll select a key map here because I have a UK keyboard. So, and pick the UK map there. Press 1 because it's the right one. Okay. Now, I already have a good partition layout for this machine on SDA, which is the, where is it? There it is. I think it's that one. Oh no, it's this one. So this is an SSD plugged into a USB to SATA converter, which is this thing here. This thing over here is the Rock Pro 64 that I use for testing. That's the SSD, that's SDA. So yeah, because it's my regular Raspberry Pi 4, it already has these two partitions, so I don't need to create a partition table. So all I need to do is just run the setup like this, and move down to add swap. And this is exactly the same as the regular installer. The only difference is that it's using the Raspberry Pi kernel fork rather than the official Linus Torvalds kernel. You may have noticed when the machine booted, I didn't actually catch it this time around, but it would have been there. And you'll see it when the machine boots as well. There's a bunch of errors from loading the some of the drivers. They're not actually errors, they're really warnings, because those particular modules aren't present in a Raspberry Pi kernel fork, and that's fine, it doesn't cause a problem, it just looks a bit ugly. And I'm not going to fix it. I could fix it, but it means writing extra code and checks. There's just no point. This is only ever going to be for experimental purposes. So let's just press enter. We don't have a real-time clock, so yes, we'll switch off FS checks. Actually, this Raspberry Pi 4 does have a real-time clock. Something's gone awry there. I don't know what it is. I'll fix it at some point. So it's saying that we have the Slackware packages in this edition of the Slackware installer. So yes, we'll install from that collection. So yes, we'll install everything, and there we go. Okay, so we'll pick this up when it's finished. All of the packages have now installed, and you can see the installer has paused, waiting for us to resume it. This is because in the Raspberry Pi 4 plugin script for SAIR, it touches a flag within the installer that simply tells it to pause before running the post-installation phase. And that's really so I can hack around with it and validate stuff. In this instance, I don't need to do any of that because I already know it works. I've tested it before. So let's just press enter. Okay, so you can see it's adjusting the configurations for the Raspberry Pi kernel fork. It's updating the operating system initial RAM disk. At this point, I'd say this is a legacy from the initial porting work. And I always remove the installer. As it explains here, I might actually just make it delete the installer because I don't think this is useful anymore. If you guys think it is useful, let me know in the comments, but I'm starting to think this is one of these things that could be just deleted. It was useful at the time. In case the installation went wrong, you could just reboot the installer, but actually I don't think so because it's reconfigured stuff at this point anyway, so I might just take this out. Anyway, let's remove the installer. Yeah, let's start the mouse driver. Yeah, we'll configure the network. We'll call it RPI4 slackware.com. Yeah, network manager. Yeah, sure. Yeah, it can stay like that actually. I'm not going to do anything else with it. Screen fonts, yes, we will. And we'll set that to TER732B, which is the one we're using right now, which is nice and large. Okay, no, I said it's a London. That's fine, don't mind about that. We can use KDE. Okay, so we can now reboot the machine. So we can just press exit in the menu and press reboot like that. We'll also see, so we'll see also the machine restarting over the serial console and over the HDMI monitor as well. And we know it's a Raspberry Pi kernel fork because you get to see the Raspberry Pi logos. That's how I know. But also you'll see there's a bunch of errors. Yeah, there we go. That's what I was talking about earlier. So you'll see those errors there. It says fatal, but it's actually not fatal because we don't because those modules are compiled into the kernel, basically. Okay, cool. As I said, I'm not going to fix that because there's no need to fix, it's just cosmetic. All right, so yeah, there we go. So we can log in now. Initially, we'll log in as the root user with the password that I just set. Okay, and I'm going to add myself my pleb account user. Yeah, we don't need to set any of that stuff, so we just put a password in. Okay, and then we'll just switch to a different console. So one of the ways to do that is just use the Alt key. So you use Alt and like F2, or you can use the Alt and the, oh, my finger doesn't reach that far. But if it did, you could press Alt and with the other Alt and arrow key, and you could switch virtual consoles as well. Okay, so let's just delete that junk. Didn't like that. Okay, so if I log in now as my pleb account that I just created, and of course I've typed the password in wrong. Cool. Right, start X. You can, by the way, configure Slackware to automatically start in the graphical environment rather than the virtual console. If you want to do that, look at the Raspberry Pi installation guide or any of the other Slackware AArch64 installation guides. It tells you how to do that. It's literally editing the init tab one file with one line. That's it, and it will boot into the graphical mode initially. Okay, so we're going to start KDE. One of the good things about this actually is that using the Raspberry Pi kernel fork, KDE actually works. If you use the official Linus Torvalds kernel, KDE doesn't work. It's egg faults. It may work in the newer versions of the Linus Torvalds kernel, but currently we're in 6.12 and it just seg faults. But it works fine with the Raspberry Pi kernel fork. We can load, where's the web browser? Probably in the internet section, I guess. Firefox, there it is. That's what happens when you don't have the real-time clock. So I'll just for an X term and just set it. Oh, I need to be root to do that. Actually, I'll tell you what, let's just switch to the other console. So Control, Alt and F1. There we go. And I'm back to my root console there. So I'm just going to set the time. As I said, this Raspberry Pi does actually have a real-time clock. But for some reason it's not detected anymore. It used to work in an older version of the kernel. I just haven't fixed it yet, but I'll get around to it. By the way, you could also just set up NTP to do this. You can set up NTP as part of the boot process, but I just don't do that really. So there we go. So that solves that problem. And there we go. Yeah, got to accept those, haven't you? And there it is. Okay, so there we go. Okay, well, I hope you enjoyed this episode. And this is just some of the baby steps towards integrating the Raspberry Pi 5 support into Slackware AArch64. So join me in a future video and we'll get there at some point. So until the next time, take care. Bye-bye.